Hello, welcome students. So in the last class we covered the method of variable separation. Now we will be focusing on the second method, that is homogeneous equation. We will be covering we will be having basically each video for all methods. Okay, just to simplify the things in a sequential manner. Okay, so what is a homogeneous function? Let us say a differential equation of the form, let us say any differential equation is given like this: function of xy, and again at the denominator there is another function of where fxy and phi xy are homogeneous functions of same degree in x and y. Okay, basically the degree should be same. So before going into the much depth, let's first discuss what is homogeneous function. Okay, so let us say if any expression of the form, an expression of the form that is a naught x to the power n plus a1 x to the power n minus 1 into y plus a2 x to the power n minus 2 into y square plus a3 x to the power n minus 3 y cube, and so on, an, and the last term is y to the power n. Can we say in every term there is degree of n? How? See, n here x is power n minus y and y, so can we say n minus 1 plus 1? This will cancel, again n. Here n minus 2 plus 2, this is again n. Here n minus 3 plus 3, again n. Here last is n. So can we say in which every term of nth degree, okay, every term is of nth degree, hence is called homogeneous, function of degree n. Okay, now we can do one thing. What we can do, we can just rewrite this thing in a decent manner. Can we say we'll take xn to the power common? Can we say a naught plus a1 into y by x plus a2 into y by x का whole square plus an into y by x to the power n. If you'll see, this expression is same. Let's multiply the first term, this is same. Okay, let's multiply this xn. Can we say n is there and below x is there, then n minus 1 and y is there, so this expression is nothing but same. But the benefit of this is nothing but this is expressed in like x to the power n, and can we see all the terms is a function of y by x. So can we say this is nothing but a different function of y by x, is also called homogeneous function, of degree n in x and y. Okay, now we have identified that how to look for the homogeneous function. So now what's the method to solve this one? Remember, these are very simple steps. Like in the first method, in the method of variable separable, we used to have x and dx on one side and y and dy on one side, and then we used to integrate. This was the first method. So this was similar to the first method, but we need to do some necessity steps. Like first, put y is equal to vx, okay, and then differentiate it with respect to x. So can we say dy by dx, and how does the differentiation work? Again, keep the first term as constant and differentiate the second term, plus keep the second term and constant, put the first term differentiation. So can we say dy by dx can be replaced by, this is 1, can we say v plus x dv by dx. Okay, so put y is equals to v, put y is equal to v by x and dy by dx is equals to v plus x dy. Okay, again next is separate the variables v and x and then integrate it. Okay, now let us say there is other method also. Let's say if your equation is in dx upon dy, let's say you want to do the process in dx upon dy, then in that case put x is equal to vy and differentiate with respect to y. So can we say dx upon dy will be replaced as v into dy by dy plus y into dv upon dy. This will get cancelled, so we can replace dx upon dy is equal to v plus y into dv upon dy. Okay, and we can, next step is just we can separate the variables and solve accordingly. Okay, separate the variables v and y and integrate. Okay, so let me give you some idea how to solve these questions. Okay, we'll solving 4 numericals, and let's see how the first numerical goes. So now you have to lift up your level. You have you should remember the integration formulas, because differential equation is all about the integration. If you know the integration, then differential equation is quite easier for you. The question is like this: solve x square minus y square dx minus xy dy is equal to 0. Okay, so first we try to change the form into dy by dx. So how will change? Can we say x square minus y square, this is dx, and take the dy in the right hand side, xy dy. Can we say dy by dx, can we write like this: x square minus y square divided by xy. If you clearly look at this, can we change this form into homogeneous? Is it homogeneous or not? Let us say, can we say if we'll divide the whole numerator and denominator by x square, so what's your answer? Can we say 1 minus y square by x square, and this is y by x. So can we say now dy by dx has changed into 1 minus y by x ka whole square divided by y by x. Now this is a homogeneous function. Okay, because we just covered here this can be written like this. Okay, so it's a homogeneous function. So can we write this, which is homogeneous in x and y. Okay, now how to solve this? Put y is equal to vx, and what does this do? Can we say dy by dx is equal to v plus x dv by dx. We just proved this. We just put y is equals to vx and differentiate with respect to x. So can we say here dy by dx will be replaced by this equation, and y by x, can we say from here y by x is nothing but replaced by v. So just replace the things from equation 1. So from equation 1 and keep it as equation number 2. From equation 1 and 2, can we say v plus x dv by dx? We have replaced the left hand side dy by dx using this, and now let's talk about the right hand side. So what is y by x? This is nothing but v. So can we say 1 minus v square divided by v? Okay, so now x dv by dx is equals to 1 minus v square by v minus v. or can we say x dv by dx, and this is 1 minus 2v square by v. Okay, now apply the method of variable separables. So apply the method of variable separable. What is the method of variable separable? Just take the v and x on different sides. So can we say, if we say v dv by 1 minus 2v square, and will integrate both side. Okay, now if we recall, in the last class we got one formula that if at the numerator there exists the derivative of the denominator, then we can directly write the results as ln of, or basically log of 1 fx, okay, plus c. So here can we say, what's the derivation of 1 minus 2v square? Can we say this is nothing but minus 4v, but here v is present, so what can we do? We can just divide the things as minus 4 divide and minus 4 multiply, and this is 1 minus 2v square. Is there any change? No, because we just minus 4 numerator and minus 4 denominator, we just put the values same in the numerator and denominator, so they will be getting cancelled. So your result will be on the left hand side, and we also know the differentiation of 1 upon x is nothing but log of x. Now it's a simple problem. Minus 1 upon 4, can we say log of 1 minus 2v square, and this is log of x plus c. Okay, now if we want to simplify the things, can we say let's multiply it by 4. Okay, so can we say 4 log x plus log of 1 minus 2v square is nothing but equal to minus 4c. Okay, just multiply by 4 and rearrange the things. Okay, you will get the same. Or can we say, if you recall the property, like I'm writing the highlighting the properties in a green ink, that is, let us say if m log a is there, can we say log a to the power m can be written? Okay, so in the same way, for log x is there, can we say log of x to the power 4 can be written, and log of 1 minus 2v square is equals to minus 4c. Let's say minus 4c. Okay, again can we say, again property, if you recall, log of a plus log of b is equals to nothing but log of ab. Okay, so two logs are there. Can we say, or can we say the next step is x to the power 4 into 1 minus 2v square is equal to minus 4c, and this is nothing but log. So how do we solve the log? Can we say x to the power 4 into 1 minus 2v square is equal to e to, here this is e to the power or you can say 10 to the power minus 4c, or this would be nothing but a constant. Let's say they presented by different constant here, hence your final solution is x to the power 1 minus 2 v square is equals to c dash. Okay, now at the last step, what you will do, let me create a space bit for you. So in the last step, nothing but just put the values. Okay, just put the values. So what are the values? X to the power 4, 1 minus 2, what is v? If you recall, this is v. So y by y square by x square is equals to c dash, multiply inside, you will get the answer as x square minus 2y square is equal to c dash. So this is your final answer. Okay, now let me do two more questions for you. Let's say other question number 2 is like this: solve x dy minus y dx is equals to under root of x square plus y square into dx. So what's the first step? We try to reframe the things into dy by dx form. So can we say x dy and take the dx common? This term will be getting into the right side. So can we say y plus under root of x square plus y square into dx? Okay. Or can we write the same as dy by dx is nothing but y plus under root of x square plus y square divided by x. Okay. Can we say if we'll divide the whole equation by x, can we write this thing as y by x plus under root of 1 plus y square by x square, because there will be one x that will be getting cancelled. Okay, so we can replace the same thing as, or we can say this is nothing but a homogeneous function. You can see this is y by x, this is y by x, so it's a homogeneous function. So homogeneous function, again, for solving dy by dx, what we used to put y is equal to vx. Okay, and what does this corresponds to? Dy by dx corresponds to v plus x dv by dx. Okay, so let's say this is equation number 1. Okay, so this is equation number 1. Now from equation number 1 and 2, from 1 and 2, if we compare the left hand side, dy by dx would be replaced by v plus x dv by dx. So v plus x dv by dx, and what's the right hand side? Can we say this is nothing but y. What is y by x? From here can we say y by x is nothing but equal to v. So put here, so this is v plus under root of 1 plus v square. Okay, now if you look at the equation, v and v are common and this will be getting cancelled out. Okay, okay, so what's your final equation? Can we say x dv by dx is equal to under root of 1 plus v square. Okay, can now separate the variables on each side. Okay, separate the variables. So can we say dv by under root of 1 plus v square, and this is dx by x. Okay, then integrate it. The integration of this is quite simpler, but this is requires a formula for you to solve. If you recall the integration formula, that is dx divided by under root of a square plus x square, this is nothing but equal to log of x plus under root of x square plus a square plus constant of integration. Okay, so this is the formula for the integration. So comparing to the same formula, okay, comparing to the same formula, can we say the result will be log of v plus under root of 1 plus v square, and this is log of x, and let's write the constant as log of c, because constant ka log ya log constant doesn't matter. We just try to make the things in looks elegance. So can we say log of v plus under root of 1 plus v square, and as we know log a plus log b is nothing but log a into b, so can we say log of x into c. Okay, take the anti-log both sides, so log will get cancelled, so v plus under root of 1 plus v square, and this is xc. And now put the values of v, that is y by x plus under root of 1 plus y square by x square, this is xc. So this is your solution. Okay, now let's talk about the third question. Okay, let's talk about the third question. So what's the question number 3? Solve x tan of y by x minus y sec square y by x, and this is dx plus x sec square y by x dy is equal to 0. So can we rewrite this equation? And in the simplify order, can we say y sec square y by x minus x tan y by x, and divide the whole equation by x sec square y by x. So this is nothing but dy by dx. Okay, if you can see, it's the y by x term is there, hence it's a homogeneous function. So what we'll do, we'll just solve the one by one term. Okay, this is y sec square y by x divided by x sec square y by x minus x tan y by x, and this is x sec square y by x, and this is nothing but equal to dy by dx. Okay, so this term will get cancelled and this will get cancelled. So what's your final term? That is y by x minus of tan y by x and sec square y by x, and now you can see the whole equation has transformed into a homogeneous function. Let's say this is equation number 1. So again here it's the dy by dx term. So how do we solve? Put y is equal to vx, and what does it leads to? Can we say dy by dx is nothing but equal to v plus x dv by dx. Let us say this is equation number 2. So from equation 1 and from equation 2, first compare the left hand side. Okay, so left hand side, let us say, or compare the basically dy by dx, because we have written this side should be this side should be this. Okay, so can we say v plus x dv by dx d? Okay, and what is this? This is now replace y by x with what? Y by x with v. So can we say v minus tan of v divided by sec square v. Okay, again if you look, v and v will be getting cancelled. So if you look at your solution, can we say x dv by dx is equal to minus tan v of sec square v. Okay, if we apply the method of variable separables, means taking v on one side and x on other side, so can we say sec square v dv by tan v, and this is minus of dx by x. Now just integrate the things. So here can we see the differentiation of this lies at the top, and if the differentiation of this lies at the top, can we say log tan v can be mentioned, and here if you say this is nothing but minus log of x plus log of c. Okay, so can we say log of tan v plus log of x is equal to log of c. Again the property that log a plus log b is nothing but log of ab. So can we say tan v into x is equal to c. Okay, or basically, or you can let me say one more step, that is log of tan v is equal to log of c, and take the anti-log. Can we say tan v into x is c, and put the values of v? So nothing but this is your final solution. So in this way we used to solve the homogeneous equation, but there are some more advanced version of this, that equation reducible to homogeneous equations. Okay, so you can practice this thing from your textbooks. Thank you.